Hello, today we are going to write equations and solve some word problems. The first type we're going to talk about you've pretty much seen before, but then we're going to move into some specialties just so you have a little bit of background on them. First, word problems. Don't panic, they're word problems. Second, read the question carefully, figure out what you're going to define and establish that variable, and then write our equation to solve it and then label your answer. Pretty much what you've always done. The hardest part is defining that variable so we stick to what we want to know. So the first one here, our translate equations. Here it says we have 5 times the sum of x and a number is 8 less than twice x. Solve for x. So right away, x is my variable, or he's just basically a number. X is my variable. With that, now I'm going to go ahead and write an equation. So I got two things going on here. I have the word is, that's going to be my equals, and I'm going to have a statement on one side and a statement on the other. So now, 5 times the sum of x and a number is 8, there's my turnaround word, 8 less than 2 times that x. So I just translated like we did in our first unit. Now I need to solve for x to figure out what x is. I'm going to distribute. I'm going to bring my variable over. Bring my number over. Run out of room. Divide by my 3, and x is negative 11. Now, x we want is a number. In this case here, the only way we define x is that x is negative 11. It's kind of different than your other word problems because we're just translating for that variable x. Our second one's a little bit different. It says, Mary got a new cell phone. Her cell phone plan is $25 per month and 10 cents per minute, unlike what you all do now. Now you have unlimited. Back in the day, you had to pay per minute of usage. How many minutes did Mary talk on her cell phone if her first bill was this? So we know she paid this much a month and this much per minute, but we want to know how many minutes. So that's our unknown, the number of minutes. Now we want to set up our equation. So we know that she charged $25 per month and 10 cents per this minute was going to equal that $150 she spent. So now solve my equation to see how many minutes she talked. Remember, when you're dividing by a decimal, your number gets larger. So now we're going to define our answer. Answer is our number of minutes. This is what our variable equaled x, so it's 12,500 minutes. And you could make a more complete sentence by saying was how many minutes Mary talked on her phone for her bill to be this. If you wanted to be more looking for just the basic answer, how many minutes did she talk? All right, number 3. Donnie and Billy have a lawn mowing service. Donnie has saved $100 and charges $15 per lawn. Billy has saved $55 and charges $25 per lawn. How many lawns till they have the same amount of money? The same amount of money means their money is equal, which is what you're going to do to Donnie and Billy. You're going to make Donnie equal Billy to find out what point they have the same amount of money. What we're looking for is how many lawns they must do to get that. So the pink is really my thought plan. So now we need to come back in and say, okay, what does Donnie do? He has $100 and he charges $15 per that unknown lawn. Billy, on the other side, has $55 and charges $25 per unknown lawn. So now they break, at that point, that's where they're going to be even or the same or equal to each other. That's how the equal comes in. So now let's solve for x. So I'm going to take 25 from both sides. Subtract my 100. So negative 10x equals negative 45. Divide by my negative 10. X equals 4.5. Now, 4.5 is where they break even, but you know that's not how many lawns they're going to mow. So this is kind of different how it asks the question. Here it says, how many lawns must they mow? Can they mow half a lawn? No, the person would get really, really mad at them. You're exactly right. So they have to mow 5 lawns to be equal. Can't mow half that lawn or that person's not going to pay them, right? So you have to physically mow because it says how many must they mow. They got to mow the whole lawn. They can't mow half of it. Number 4 is like that weird one we kind of had on our last test as well. It puts things in bullets. It says Mary and Billy want to start a savings plan to save money for a new earbuds because earbuds are darn expensive. How many weeks will it take for Mary and Billy to have the same amount of money? Again, ding, 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 same amount of money where they're going to be equal. So it's just like Donnie and Billy. We want to know where Mary, and this is a different Billy, are going to be equal. So we know there's 2 plans. That's like that bullet stuff we had before. Mary has $120 and wants to save $20 per week. Billy has $100 and wants to save $25 per week. So what we want to know is how many weeks. So that's my unknown, the number of weeks. So now let's set them up. Mary has 120 and she's doing 20 per week. Billy has 20, oops, sorry, not 25. He has 100 and he wants 25 per week. So now let's see how many weeks. Let's solve for our x. So I'm going to bring my 20. I like to bring my variable over. You don't have to bring it over to this side. You could bring it to the other side. I like to bring it over to the left. That's just a personal thing. So when x equals 4, that means that's my number of weeks. So it's 4 weeks. They'll have the same amount of money. These 4 on the back are just 4 different types of problems that you will see. The first one is a break even, which is what we've been doing now. Where do Mary and Billy break even? Where do Donnie and Billy break even? The difference is with a break even, we're talking about when do you personally make your own profit against yourself. Same idea as Mary and Billy and Donnie and Billy. Same idea, but where do we break even in our money? That's what we want to know. When do we start making a profit? So it's usually in a business. So I want to start talking about the money. When you're talking about breaking even, well, you got money you're going to take in and money you got to put out because you want to take in money so that you can break even. So suppose you start an office cleaning service. You have spent $315 on equipment to clean an office and must use $4 worth of supplies. You charge $25 per office. How many offices must you clean? That's what I need to know. How many offices? So now we know that our money out has to equal our money in for us to break even and start making a profit. I put out this much money to start a business. I got to recoup that money before I can start making a profit. All right, so what did I spend out? I spent $350 on equipment and $4 worth of supplies for each office. What am I taking in? $25 per office. So now, solve my equation. So when I solve, 15 equals the x. X is my number of offices, so 15 offices. The next one we have is a ratio and a proportion. With a ratio and a proportion, you're comparing something. You're going to have some kind of comparison going on because you're going to have that proportion, which is two ratios on the side. Here in our example, it says, when rating movies in 1994, Gene Siskel gave 4 thumbs up to every 5 thumbs up given by his partner, Roger Ebert. So we know we're comparing this guy Siskel to this guy Ebert. They used to be, fun fact, you have Rotten Tomatoes now. They used to be the people that went in, saw a movie, said, hey, we like it, we don't like it, instead of rating it by Rotten Tomatoes, that kind of stuff. So it says, he gave up 4 thumbs up to every 5 thumbs given to his partner. So I had to read that very quick. Now it says here, that's my comparison. All right. If Siskel gave us 68, that means Siskel's in my numerator. I have to put the 68 in my numerator. How many movies did Ebert rate favorably? We don't know. That's my unknown is Ebert right here. Solving any proportion. So cross multiply. So we know that here, Ebert rated favorably 85 movies. 85 movies. Now, number 7. Number 7 is one of my favorite. They're word problems. Not word problems, formulas. Why do I like formulas? I love formulas because they tell us everything we need to know. Everything I need to solve my problem is in the formula. So I love that the formula is there so I can solve my problem. It says, this formula here is used for placement services for keyboarding spreads. When you go in and you want to work in an office, like you might want to work in a dental office, you might have to transcribe dental records. They need to know how fast you can type. Going and working in a law office, you got to transcribe law documents. When you're a secretary, you got to do a lot of typing, and they want the person who can type the fastest, they can do more work, right? Pay them less money to make them do more work. It says, in this formula, W is the number of words, E represents the number of errors, M is the number of minutes, and S represents the speed in words per minute. So now, 10-minute keyboarding test, that's my minutes. 420 words, that's my words. 6 errors, that's my errors. Find my speed, that's my S. So it tells me everything I need to know, which makes my life so much easier. So my speed equals my words, which we said was 420, minus 10 times my errors, divided by my minutes, which was 10. Now I'm just going to use order of operations to solve. Just as a sidebar, remember he's in a hidden parenthesis. Must solve him first. So when I solve my equation, yes, I know I solved it quickly, I get 36. That's what my S is. So it's 36, and my S is words per minute. Right here it tells me, oops, that's a really weird, I put an extra W in the words, but what were words per minute? Were words per minute. There we go. Now I feel better. Words per minute. All right, our last but not our least is consecutive integers. When we're talking about consecutive integers, we're talking about things in order. That's what consecutive means. So if I have the number 8, who's his consecutive integer? Exactly, 9. If I have 10, who's the consecutive integer? 11. If I have 100, who's its consecutive integer? 101. So when we're defining our variable, we know that these 3 consecutive integers is going to be 237. So x is going to be my first integer. So to get to the next number, so if he was 9, we had to get one more, we had to add 1. Exactly. He's going to be my second integer. Now, I'm going to have to add one more, so it's x plus 1 more. X plus 2 equals my third integer. Because if he was 10, he'd be 11. he would be 12. Now, these three together, equals my 237. So now when I solve, I combine my like terms. It tells me what x equals, but that's not my answer. It wants to know the integers. The first one is 78. I add 1, that's 79. I add 78 plus 2, that's 80. These are my three integers, and if I add them together, I should get the 237. Just as a sidebar when we're talking, you might see something that says consecutive, even or odd. They're not harder, they're a little different. But if you think about them, they set up the same way. If I have just some numbers right here, if I'm at 1 and he's x and I want the next odd, what did I have to do? I had to add 2. If I wanted the next odd, I have to add 2 more. So when I'm setting these up, x is going to be my first odd, x plus 2 is my second odd, and x plus 4 is my, third odd. So with that, it's the same with my evens, because if I'm jumping here, I'm still jumping 2 if he's my x. If I'm here, I'm still jumping 2. So it is the same for both of those. Oops, that should be even, sorry. That should be even and that should be even. So if I'm jumping with even or odd, I'm not sure if you have even or odd, but if you do, you need to know how to set them up. If you have any questions, please ask. I appreciate it. Thank you.